Hello Bacho, let's read this question. A capacitor is charged by using a battery which is then disconnected. A dielectric slab is slipped between the plates which results in which of the following? So what happens when a dielectric slab is slipped inside? So this is the capacitor with which is being charged by using a battery, and now it has been disconnected. So there is no connection between the two plates. There is no connection. And now what happens is there is a dielectric slab which is slipped slowly inside. So in this case what happens is there is charge Q on each of the plates, but since there is no connection and the dielectric is insulated, it is insulated and it is not in contact with the plates, there is no change in charge. So the charge in between the plates is going to be constant. On the plates is going to be constant. There is no change in the charge. So now what happens is since the charge is constant, we have the C dash or the new capacitance as Kc. Since if we push in a dielectric constant K slab, the capacitance increases from C initial to K times C for the new capacitor. So what happens is we have potential energy as Q square by 2C. This is the initial potential energy or U naught. This is C naught. Now what happens is there is new potential energy U dash which will have Q square. Since this is constant, there is no change, divide by 2 C dash, which is going to be Q square by 2 K times C naught. This is C naught. So in this case, as you can see, initially it was Q square by 2 C naught, now it is Q square by 2 K C naught, and K is greater than 1. K is greater than 1 for any dielectric slab. So what happened is U dash is going to be less than U naught. This is the first inference. Now the second thing we can say is Q is equal to CV, or we can say the potential difference is nothing but Q divided by C. So in this case what happens again is this is V dash is equal to Q by C dash. So V dash is going to be equal to Q by C naught times K. This can be written again as 1 by K times the initial V naught. So since K is greater than 1, we can again say V dash is going to be less than V naught. So the potential difference has dropped and the potential energy has also dropped, but the charge is constant since there is no connection between the plates at any point in time. So as you can see in option C, it says decrease in potential difference across the plates. Decrease in potential difference, decrease in potential difference across the plates. As proved here, we have a decrease in potential difference. So this part is true. This part is true. Reduction in the stored energy. As I proved here, there is a reduction in stored energy. So this part is true as well. But there is no change in the charge on the plates. So since there is no connection between the plates, there is no change in the charge. So this part is true as well. So since this whole statement is true, we can say that the correct answer for this question is going to be option C. Decrease in the potential difference across the plates, reduction in stored energy, but no change in the charge on the plates. ठीक है बच्चों, I hope you understood the solution. Correct answer is C. Thank you very much.